Before we get started, who has already used Java 9 or is running on Java 9? A few brave souls, okay, very well. So as for the rest of you, congratulations. Since September last year, you're actually building legacy software now, right? Because that's when Java 9 came out. So, but we're going to change that. But you're here now, you're about to hear about all the changes that went into Java 9, and they're pretty significant. Even if you're not going to use modules, you will encounter probably some issues when migrating to Java 9. So, hence this talk. Now, of course, we're not going to migrate everything to modules directly, and you might be thinking, so I have a code base on Java 8, I just run it using the class path, it's inside a jar file, for example. So Java has always been very big on backward compatibility, right? So I should be able to just run the same application on the class path in Java 9, shouldn't I? And I like the way you're thinking, but, well, there are some caveats, and we'll see about that. So in principle, this scenario is true, but it only works if your application and your libraries, etc., don't use any of the internal implementation details of the JDK. And as it turns out, many libraries that we do use have actually abused these internals of the JDK. And this will come back to haunt us when we're moving to Java 9 or to Java 10 or even later. Because, I mean, it's time to get with the program, people. We already have Java 9, Java 10 is coming this month, Java 11 will be later this year. And it will all feature the same change that you will have to make from Java 8 to either Java 9 or 10 or 11. So you might think, okay, I'll just wait it out for a bit, but you will encounter these issues. So good on you for being here, and I hope I can at least show you what to expect when making this move and how to solve the actual issues that you might encounter. So what we're going to do today is we're going to first talk about the act of moving from Java 8 to Java 9. We're not even talking about modules yet. We're talking about just taking your application as it is on the class path and getting it to run in Java 9. This is always the first step, and you know, it may also be the last step for your application, because not every application necessarily has to be modularized. And we'll talk about some of the benefits of modules, and I think most of you have actually already seen some introductory talks around modules, either by Oracle or by me or some other people. And these are always great stories about new applications being built using modules and getting all the benefits of the module system, which is great, but we have existing code bases, right? And we care about taking these into your future as well. And some of them are really fit to be ported to a modular world, and some of them, well, they might be sort of messy, right? We do occasionally write messy code as Java developers. Sorry about that. So in those cases, it might be the last step to just take it from the class path on Java 8 to Java 9. But of course, there are many applications that we do want to keep extending, that we do want to take into the modular future. And in that case, we want to see how we can actually take these applications and turn them into modular applications. So we're going to do that today with an example application. I'll introduce it later. But the point here is that even if you're not going to use modules, you will have to move to Java 9 or 10 or later. You might encounter some issues, so we'll first look at that. But after that, we're going to look at how to actually reap the benefits of modularity. So why am I so interested in modularity? So I work at Luminous, which is a Dutch software technology company, and we don't only do projects and consultancy, but we also develop our own products. And as people who develop their own products know, this is a different kind of ballgame, right? If you're creating code that you have to maintain for 4, 10, 15 years, you make different choices. And for us, modularity as an architectural principle really helps drive these decisions to make maintainable code, to create extensible code, which allows us to be more agile. So all in all, this principle of modularity is really important to us. So we used to do this using, for example, OSGI or other module systems on the Java system platform. But obviously, once Java 9 was going to get a module system, this really piqued my interest. And this is also why I dove very deeply into it quite early. Now, we're about to migrate an application. And this is a typical, what I would say, legacy Spring Hibernate application. This is not a very modern Spring Boot 2.0, Spring 5, whatever application. This is just a Spring 4 application using Hibernate. There's even some XML configuration still in there somewhere. It's also using annotations. So this is fairly representative of an application that most of us run in production. And As you can see, it's not a very big application, but still it hits all the points. It has a repository, it has some entities, it has some services that needs dependency injection. So this is what we have. This is what we're currently running on Java 8, and we're going to take it to Java 9. And we'll see that in Java 9, we actually have a modular JDK underneath, and we'll talk a bit about that more in more detail later. But it actually means that Java itself is subdivided into modules. The JDK itself is subdivided into modules. But our application is still on the class path. So all of our dependencies, and well, let's face it, if you're creating a Spring Hibernate application, you do have a lot of dependencies. They all live on the class path. And as you can see here, this is only a subset. Our application code in orange is also there. But what might catch your attention is that the class path now also has a different name. It is also known as the unnamed module. Because it turns out if you're running code from the class path on Java 9, it's actually already inside of a module, even though you didn't put it there. The JVM will do that for you when running the code. And we'll see that this unnamed module is sort of a special module. It behaves as a normal class path, but still it's already a signal that something has changed in Java 9. Something has fundamentally changed. So what we're going to do is we're going to just try and see what happens if we take our application from the class path in Java 8 to Java 9. So let's go. Here we have our application. It's just structured in a couple of packages, some APIs, some implementation packages, just to show that it's plain Java code. It's just using some Spring types, etc. So we have a main bootstrap application context. We have a book service, a bookstore service, all Spring Beans. We're going to create some books using the Hibernate repository, and we're going to retrieve the books again and use the bookstore service to calculate some total. So just to illustrate, there's nothing really special about this code anyway. So I do have a little script here that just sets up the class path, compiles our code, and runs the application. So fair warning, there will be command line compiler invocations in this talk, and there will be code, and there will be errors. So if you're not up for that, you can still leave. I won't make fun of you, and now's the time. So let's just run this and see what's going to happen if we're on Java 8. So just to make sure, I want to be on Java 8. Let's verify. Yep, there we go. And to run my script. There we go. And as you can see, it compiles, it starts the application, Spring does its thing, takes a while. Oh well, we have time. And there we have our outputs. So it created some books using Hibernate, retrieved them, and did the calculation in our service. So now I'm going to stepwise approach this, and I'm going to not run the application. I'm just going to first see if we can compile it using Java 9. So the first thing to notice is it's not Java 1.9 anymore, it's Java 9. So we can say set JDK 9. I think it's a good thing this prefix has been dropped because it was really useless. But now we're hopefully on Java 9. And indeed, there we have it. We're currently running everything on Java 9. So if I run my script now, containing only the compilation, it works. Yay, for backward compatibility. So that's good. So now let's try to run this application. And we're going to use the same script again, compile it, it boots, looks hopeful, and then we wait a bit more, and it shatters all of our dreams about backward compatibility, because, well, the application doesn't run, does it? It gives us a class not found exception, Java XML bind JXB exception. So what's up with that? What we see here is one of the three major problems that you can encounter when you move to Java 9 or later. So there are some modules in the JDK, which are so-called enterprise modules, which now with Java 9 aren't resolved or available by default anymore. So we'll look into that problem. There are also some libraries and even application code that abuse platform internals of the JDK. And this will behave differently on Java 9 as well, as it did in earlier versions. A third class of issues that you might run into is that there might be split packages between some of the libraries that you're using on the class path and packages that are actually inside the modules in the JDK. Now, this is somewhat rarer, but if you use, for example, the add nullable annotations from JSR 305, etc., this is a really common issue. And what happens is that the class path types in this package will be ignored, and it will only in the JVM see the packages that have been shipped with the JDK itself. So that will probably break your application. We're not going to look in the third issue today. We're just going to stick to what we encounter when migrating this application. So that will be the first two issues. But this is definitely also something to be aware of. So let's try to bring this problem that we just saw at runtime back into a small, reproducible compile time example. So if we take this code where we have a main class using just some simple data type converter class from the Java XML bind package, then we can't actually even compile this code with Java 9. And it actually has the same root cause as the runtime error that we just saw. What happens is that we now have a module graph of all modules inside of the JDK. And this exists regardless of us using modules or not. So even though our application is still on the class path, it will run on top of this modular JDK. And of course, it's great that we now have a modular JDK because we have all these explicit dependencies, and it makes evolving the JDK much nicer, etc., etc. But there are some repercussions for us. So if you look closely, you'll find there's a module, java.xml, that binds, which does include the package that we just talked about. And it's in the module graph. It's in the complete module graph of the JDK. So that sounds promising, right? But if you look closely, it's only reachable from the java.se.ee top-level node. And EE here stands for Enterprise Edition modules. Now there's also a Java SE node in the module graph, which groups or aggregates all of the Java SE modules that are available in the JDK. So there is a set of modules that is not reachable from Java.SE, but is reachable from Java SE.ee. Now, what happens if you compile or run code on the class path with JDK 9 is that the compiler and the runtime actually resolve everything that's beneath Java SE, but not anything that's beneath Java SE.ee only. And there's a reason for this. The reason is that they actually want to get rid of these EE modules listed here. So Corba will be gone, actually, with Java 11. Yay. And Java XML WS, same story, etc. So this is actually something that will change in a future release. The modules are still there currently, but they're not resolved by default if you're compiling on the class path or running on the class path. So it's sort of a pity that we only found this out when running the code, right? So what you can also do is you can also use a tool called Jdeps to analyze your existing code and see if it has any of these dependencies on unresolved modules. And what it will look like is you provide the main class in this instance, and it will show you all the dependencies that it has. It has a dependency on Java Lang, which is a typical package that everybody uses, which is inside of the Java base module. And the Java base module is sort of at the bottom of the hierarchy. Everybody has a dependency on Java base. It contains foundational classes like Java Lang object, the string, collections, utils, etc. But the not found is, of course, the interesting part here. So it has a dependency on the Java XML bind package, but it can't resolve this by default, and it will tell you this with the Jdeps tool. So there are some solutions that you can take. So at compile time, you can use the add modules flag and tell it, for example, to explicitly also resolve the Java XML bind module for your application to compile against. So this works, and you would have to do the same at runtime. But at the same time, I just told you that these modules are not resolved for a reason, because they're going to be removed. And they're actually going to be removed in Java 11. So the best solution to this problem is to find an implementation of the Java XML bind API yourself and add this to the class path, just like you would with any other library dependencies. So here, I mean, you do have a choice, and for now, we'll choose the easy way out. And in Java 9 and Java 10, this will work, but in Java 11, you will have to provide your own implementation. So that being said, this should fix our issue, and let's see if it's actually true. So we're going back to our run script. We're going to say add modules java.xml.bind. There we go. And we're going to run our application, and this should fix the class not found exception that we just saw. So we haven't touched modules in our application yet, but we still ran into an issue due to the modularization of the JDK. Now, This is, like I said, always the first step. So taking a Java 8 class path application to Java 9 class path. And this will give you access to all the new APIs. In Java 9, it will give you access to the performance and security improvements, etc. But it doesn't yet really give you any benefits of having a module system for your application. So let's look at modules next. But before we do that, we actually have to go back to what we just saw. Because if you were very, very attentive, you might have seen that there was a warning in our output. And this was not a warning that is printed by Spring or our application code. This is actually a warning that's been printed by the JDK itself, which is fairly invasive, right? Normally the JDK doesn't really print anything to the console for us. But here it gave us a warning. It says, an illegal reflective access operation has occurred. Ooh, that sounds very bad, right? So it says, there's an illegal reflective access to Java Lang class loader define class, which is apparently a method on the class loader class. And it turns out that the Java Assist library that Spring uses internally uses this kind of class loader hacking to do its work. Now, apparently, this is no longer a good idea because, well, it's a private class which you shouldn't actually use. So Java Assist must change. So the first thing the warning says, okay, please consider reporting this to the maintainers of the library, in this case Java Assist. And actually they fixed this. So a lesson here is, if we would have upgraded to the latest version of all of our dependencies, we wouldn't even see this issue. But if you did see some of these issues, some of these warnings, it also points to some piece of library code that actually abuses internal implementation details of the JDK. And it also says at the bottom, all illegal access operations will be denied in a future release. So we're still playing nice, right, in Java 9. But in a later version, this warning may be turned into an actual error, breaking your application. So for now, what you can do is you can work around this by explicitly allowing this Java Assist library to break into the java.lang package of Java base with the add opens java.base. So inside module Java base, we're going to open up the Java lang package where the class loader class lives, and we're going to open it up to all the unnamed modules. So all pieces of code that are running on the class path. And this should hopefully also take away our warning. And we're not going to try this, but you'll have to trust me, this works. So more generally, what happens if you have code that uses encapsulated APIs? So here again we have a small reproduction of this scenario, but now at compile time again instead of at runtime. And here's a class that uses Sun Security X509, X509. I mean, who doesn't use it, right? So it uses this class, and this works perfectly fine on Java 8. However, if you're trying to compile this on Java 9, it will actually actively disallow this, because you shouldn't be using this, and now it's truly encapsulated in a module in the JDK. You can't even compile against this. So again, if you want to find out by other means than just looking at compiler errors, and also see what alternatives are available, use the Jdeps tool. In this case, you can provide a JDK internal flag as well. And if you provide it with the code that you want to inspect, it can be a class, it can be a jar file, it can be multiple jar files even, then it will also scan for uses of these internal and deprecated APIs. And it will give you a replacement, which, by the way, has been available since Java 1.4, so well, you're still using this. But at the same time, this is really helpful to audit your own code. And I think in general, it will be mostly libraries that abuse internal types. But there are also some occurrences of uses of, for example, base 64 encoding and decoding types that are in private packages of the JDK that are quite popular in application code as well. And this will break if you move to the Modular JDK in Java 9. So, I mean, what we just saw was code that was actually compiled with Java 8, so the Java Assist code. And we ran it with Java 9. And that works because we're in the sort of lenient transition phase to a full encapsulation story in the JDK. So we only got a warning, but the code still ran. In the future, this will most probably be the default of the JDK. So there's an illegal access flag, and by default it's set to warn. But if you set it to deny, then it will actually throw an error. and it will just fill your code. So your goal should be to be able to run your application using illegal access is denied. And if it runs with that, then you're completely ready for the future of any other Java releases that are upcoming, and that will tighten the screws further on encapsulation in the JDK. So if you really can't change your code, then what you can also use is the add exports flag, and we'll talk a little bit about the difference between an open package and an exported package later, if we talk about modules themselves. But here we're still in the class path situation, and in this situation we can say, okay, we're going to export the package sun security x509 to, again, all unnamed, which is the class path, and use that to run and compile our code. And again, this will work around the problem, and this will at least get you up and running again. So, looking at class path migration, first, you should always upgrade to the latest versions of tools and libraries. So lots of these issues have been teased out already for you. So you won't run into the issues that we just saw, hopefully. And if you do, then really try to contact maintainers and point them to their responsibility to make it work with the future of Java. So again, use Jdeps to find any of the potential issues, like these dependencies on the enterprise modules or use of JDK internal APIs. Well, split packages, I've talked about that, but we haven't seen any example of that. And try to fix all of the illegal access warnings, either by using these command line flags, which is sort of a weak workaround, or by changing your code, if it's your code that's breaking the rules, or upgrading to later versions of the libraries that don't do these illegal accesses to internal JDK types. But, I mean, we have a class path application and we're on Java 9, so we want to use modules as well, right? And before we're going to look at how to move this Spring application into the modular world, let's first talk about why you want to do that. Because typically, what we have in our whiteboard designs is a very nice architecture diagram, right? So we have a main sort of part of the application that uses a books API, and there's a bookstore part of functional part of the application. There's an implementation of the API. It's all nice and clean. But, well, if we really think about it, at runtime, our view of the application is a bit more miserable. It's the class path, right? Just a bunch of jar files on there, and there's absolutely no structure in the class path. So there are no explicit dependencies between these jars. It's easy to miss one, and it will only blow up at runtime. It's easy to have multiple versions of your libraries or even your application code on the class path, and it may or may not work depending on whatever happens in your code. So this is generally a bad place to be, and it doesn't really reflect what we just saw. So if we're going to use modules, like the modules are used in the JDK itself, then this will become a possibility, and we can get help from the compiler and from the JVM in establishing modules by also defending the module boundaries and having the means to encapsulate code inside of modules. So before we move on, a short primer on modules. Modules are, you can think of them as jar files containing extra metadata in the form of a module descriptor. A module descriptor looks as follows. We see two here. There's one for a module main and there's one for a module bookstore. And as you can see, this module main has a require statement. And it says, okay, this module main requires the bookstore module, meaning that it actually needs the bookstore implementation to do its work. So it's probably accessing some code inside of this bookstore module. So you need to be explicit about this. And the module system in Java 9 helps us to actually verify whether all modules are available if we're going to start the application. So if we would start this module main without the bookstore module being available, it will already be detected at resolution time. So there will be a resolution phase in the module system where it takes all of the module descriptors, all of the module info files, and it will try to see if we have a valid module graph. So that's already quite helpful. On the other side, we have exports statements. And if we look at modules, I said they're like a jar file with additional metadata, but they also behave differently than normal jar files. If you have some public class in a package in a jar file on the class path, it's accessible to any other class on the class path. So there's no real way to do encapsulation, and the JDK team found this out the hard way when they actually had this problem of encapsulated APIs that were being used in libraries and application code. So we have this on the class path. Now, a modular jar actually doesn't expose anything to the outside world, only if you tell it to, using an export statement. So here we say that the module bookstore exports the package bookstore API.svc service. And any other packages that are inside of this module will be encapsulated, meaning that if another module has a dependency on bookstore, it won't be able to access this code. It won't be able to use this code in packages that haven't been exported. So this is a really good way to be deliberate about the API of your module, of your component. And the smaller your API is, the better, of course, because it will help you support only the parts of your module to the outside world that are actually part of your contract. And all of the internal implementation details you can rename, you can refactor, you can do whatever you want. Nobody in the end gets to see it. Now we also have a concept of open packages. And you can think of open packages as a sort of in-between full encapsulation and an exported package. Because what happens actually in our applications is that we don't always have this real nice boundary between what is API in our code and what is implementation details. Because, for instance, if we're using Spring, Spring needs to reach into our implementation classes to instantiate them and to be able to inject them, maybe even into private fields of other classes. So Spring and Hibernate and all these other tools that make heavy use of reflection actually need access to the internal implementation details of your modules. Well, you could, of course, export the code in that case, but it doesn't really feel like a good solution because it would also mean that other parts of your application can now compile against these implementation classes, these implementation details. So we don't want that. So what Opens does is that it allows all modules to access, in this case, the bookstore impl package only at runtime. So at compile time, there's still encapsulation. You still can't compile against anything that's inside of bookstore.impl, which is what you want. You want to have nice service interfaces rather than talking to implementations. But at runtime, libraries like Spring and Hibernate are still able to break this encapsulation at runtime and use reflection to instantiate your service implementations, your entities, and so on. So this was a quite quick overview, but we'll see all of these features coming back in our migration path. So how are we going to go about migrating to modules? It's very tempting to really dive in directly and already try to chop up your whole application into multiple modules and get it to work. But it turns out that there are some technical issues still that we need to work out if we're going to create a module, if we're going to create modules for our application. So what we're going to do is have a look at how we can do this in a simple way. And another issue that we encounter is the fact that, well, we might be able to create a module or modules from our application, but that doesn't mean that our dependencies are already modules. So how does it work? So before we go to the Spring application back again, here's a simple example where we have a simple demonstrator file that has a dependency on commons lang, for example, and it will run on top of the Modular JDK, but it's all still on the class path and it works fine. And in this demonstrator jar, there's a single class that uses leftpath from Apache commons lang, because we all learned from the JavaScript folks that we need an external dependency for that. So there we go, and this works fine in the class path situation, right? So we have commons lang on the class path, we have our compiled class, we run it, and all is well. But what if we want to make our demonstrator application into a real module on the module path in JDK 9? Well, if we're going to have to define the requires relation for this demonstrator jar, then we would have to express our dependency on this class path library, commons lang. But from a module, you can't reach the class path anymore. You can't reference the class path anymore. And that's a good thing because we want all of the assurances of the module system. So it wants to create a real module graph. And if we would still be able to reference the class path, then all these promises of the module system will break down. So that's a good thing. But, well, it does pose the question, okay, how do we turn this commons lang into a module? Because it's not our code. I mean, we could patch it, but that will be bad. And it might work for one library, but it doesn't work if we have 30 or 40 dependencies. we might create a pull request or do open an issue at GitHub or whatever. But again, we would have to wait, which might be viable for a single dependency, but again, not if you have 30 or 40. So what's the story here? So fortunately, there's a migration story for jars that haven't been modularized yet too. So what you can do is you can take a plain jar file and you can take it from the class path and put it on the module path in Java 9. And this will turn it into an automatic module. And an automatic module isn't a really great module, we'll see that, but at least it's usable as a module in the modular world. So we'll get a module name that's derived from the jar file name, which isn't great, of course, because well, anybody could change the file name. Or it is derived from an automatic module name header in the manifest file of a jar file, which can be really easily added by library maintainers, much more easily than creating a full module descriptor and going to Java 9 fully. So that happens in a lot of cases already, that these names are put into the header, the manifest files of jar files. And then this automatic module will export everything, which of course is bad because there's no separation between implementation and API anymore, but well, we don't know the intent of the library, so this is the best we can do. It also reads all other modules that have been resolved into the module graph because, well, it still doesn't have a real module descriptor expressing the dependencies of the library, so again, this is the best we can do. And it also, unlike the modules that we can create, an automatic module also has access to the class path. So as far as the library code goes, for the library code, it feels as if it's on the class path, but for us, from a module point of view, we can actually refer to this automatic module now from our module descriptors. So this way we can modularize our code without waiting on our libraries to become Java modules, which is good. So now in our demonstrator jar, we can say requires commons length 3, and we can compile using the module path and the module source path, which you should use to compile modular applications. And once we've done that, we can run the application also using the module path. And there's a -m instead of -jar to start modules instead of plain jar files. So this is the way to approach a migration with dependencies. Now we have a bit more than a single dependency, of course, in the case of our Spring application. So what we're going to do first is we're going to create a single module around our whole application. And we're going to do this to tease out any of the difficulties that we might encounter when using these automatic modules. Because we do actually code against several of these APIs in Spring and in Hibernate, so some of these libraries will have to move to the module path and become automatic modules. So the first step that we're going to take is we're going to actually create a module info.java with a module descriptor for our application. Another step that we see here is that we get another level of indirection in our source tree. So we now, besides just having packages in directories, we also get a module directory. So we call it book app now. And in this book app directory, there's the packages in our code, and there's also module info.java. So let's see how that works. There we go. So we're going to compile and run this application now, and as you can see in our source directory, we have the module directory containing our packages, which are just the same packages that we had on the class path, but now there's an additional module info.java. So if we do this with an empty module descriptor, then it will complain to us, okay, your code is referencing types that are not in the module graph, that are not required. So what we need to do now is we need to add a require statement for each of the libraries that we're using directly in our code, so that we're coding against. So that will be the Spring Context API for the application context type, Spring TX for the annotations that we're using on our repository, some of the Hibernate core APIs and JPA annotations. And these are all now on the module path as automatic modules. So we're not using a new release of Spring, we're not using a modular release of Spring or whatever. It's just taking these old jars and putting them on the module path rather than the class path. Now, if we do the same again, then we get an interesting error. And it says, okay, apparently there's some session factory code with get current session, and it gives back some type that implements referenceable, but Well, it says, okay, I can't find the class file for JavaX naming referenceable. Now, this is in a module in the JDK, and it's not encapsulated. So what's the problem here? Why didn't we see this in the class path situation? Well, in the class path situation, we just saw everything that was underneath Java SE, right? All of these modules, and this included the JavaX naming module. Now, in the modular world, we're explicit about which modules end up in our module graph. And here, we're requiring the Spring, Hibernate, and JavaX Inject modules. But these are all automatic modules, and they don't have their own module descriptors. So if, for example, Hibernate would have a dependency on whatever is in the java.naming module, it doesn't express that yet, because it doesn't have the module descriptor yet. And in the end, of course, when Hibernate does become a module, it should express this dependency, and then the module system will be able to resolve this Java naming module automatically for us. So then life will be good, but until now, we need to fix this situation. So because our Hibernate core has this dependency on the Java naming module, we need to somehow add this module to our execution. So we could do this by adding a new require statement, but that would be sort of bad, right? Because we don't really reference code in Java.naming ourselves from our application code. It's actually this transitive dependency that's happening. So what we can do there, in this case, I'm going to open the right run script. What we can do there is again use this add modules directive that we've seen earlier as well in the class path situation, but now we're going to use it in the modular world. And we're going to add this Java naming module explicitly to the module graph that will be resolved at compile time. And by doing this, because Hibernate was an automatic module and it will automatically get a dependency on all resolved modules, and we're now making sure that Java.naming is resolved, now we won't see this error again. So indeed, we get a successful compilation. So let's move on to running the application. And what I've got here is just our original class path minus all the jars that I moved to the module path because we need them as automatic modules. So we have these modules on our module path, and our output from compilation we have there as well. And we're going to start our book app module and the main class that's in there. So let's try this. And this is sort of disappointing again, right? So we get a class not found exception, Java SQL exception. So what's happening there? And this is actually the same issue that we ran into at compile time with Hibernate, we now get at runtime with Spring. Again, Spring is used as an automatic module, so it doesn't have a module descriptor yet. It doesn't really express its dependencies. But it does have a dependency on java.sql and java xml.bind. And we saw that one previously already. So in this case, again, if Spring becomes an explicit module, and this is poised to happen in the Spring 5 release cycle, as far as I know, but currently it's not yet, we will have to fill the void and make sure that these modules that we already saw are available at runtime. So let's do that, and at the same time, let's also open up the Java base module and the Java Lang package, because we still have Java Assist doing its nasty reflection on the class loader. But in this case, we're not opening it up to all unnamed, not to the class path, but to Java Assist, which is running as an automatic module on our module path. So only Java Assist will be able to break into the Java Lang class loader in this case. We can be very explicit about that. So now if we run the application, we still have an issue, but this is not some low-level technical issue. This is really about the design of our module. Because, as I said, if you have a module descriptor that doesn't export anything, then it means that nobody will be able to access your code. Not even Spring or Hibernate or any of the other libraries that will try to do reflection on whatever is inside your module. So, in that case, we of course need to be explicit about the API of our module. So in this case we have two packages, the service package and the entities package, that are explicitly API, which is also in the package name. It's convenient. But we also learned about open packages, right? So the packages that need to be opened contain our implementation classes of the entities, of the services that we want Spring to instantiate and to inject into. So by opening these packages, we allow Spring and Hibernate to use reflection on our internal implementation types, while at the same time, we still can't compile against these packages from other modules, which is exactly what we want. We want to prevent our fellow developers from abusing these types, but at runtime, well, we can just be a bit more lenient. It also does show you how invasive these dependency injection and reflection-based libraries are, right? Because they really need this kind of access to your implementation class and your implementation code. So if we have this in place, then we can try this again, and we finally have an application that boots, that's compiling on Java 9 as a module, and that is using all of these libraries as automatic modules and giving us the same behavior as we had before. Now, this default encapsulation break that we talked about with open packages, this is, like I said, this is not something that's a real low-level technical issue. This is really about, okay, so what do you really want to expose from your module to the outside world? This is something that you should think about. And these open modules or open packages allow you to allow these libraries to do deep reflection, so also access private fields and other internal details of classes, while still disallowing this at compile time. So an open module is a module where all packages are opened. And if you look at exports, opens, from a compile time and reflection perspective, if you export a package, then it's accessible at compile time for other modules. If you do reflection on exported types and exported packages, you're able to do so, but only on the public parts of these exported types. So you won't be able to pry your way into private or protected or whatever members of classes that are exported. So deep reflection is not possible on exported packages. Open is the opposite. So at compile time, no other modules can use this code, but at runtime, you can do reflection, and you can do reflection both on the public parts of the types, but also so-called deep reflection on the private parts. Now, you can combine exports and opens, which is fairly rare, but technically it's possible, and then you would have this full array of access to the code in your module. Now, of course, we didn't set out this journey to end up with a single monolithic module, right? So what we really want is to achieve our goal of creating multiple modules which have their nice boundaries and which we can use to, in the future, extend our application and where we actually get some of the benefits of using a modular architecture. So I can show what this looks like, and we're not going to have time to go into too much depth, but all of this code is on GitHub, and I'll give a link later so you can find it. If we look at the modular Spring solution, it actually has these 4 modules that we saw on the slide. So we have a main module, and if we look at this module info.java, it's fairly self-contained. It only requires the Spring Context API, right, to bootstrap the application context that we saw. And for the rest, it only knows about the Books API and about the Bookstore package. So there's no entanglement anymore with Hibernate, etc. This is all contained in our book implementation module, which, as you would expect, has the requirements on Hibernate types and has to open its packages for Hibernate to instantiate the entities and the services. So here you can already see that the concerns are nicely separated, and there are explicit dependencies between all of these modules that are checked by the modular system, both at compile time and at runtime. You also see 2 patterns here. So we have the books part of our application is separated in an API package and an implementation package. The Bookstore part actually combines the API and the implementation in a single module. Again, this is a design choice that you get to make. But in the case of a combined implementation and API module, then you would have to export your API package, and you would have to open up your implementation package for Spring to be able to do its magic. So I would advise you to take the time to go to GitHub and check this out in a bit more detail and really see what's happening between all of these modules. It will give you a very nice overview of all of the features of the module system. Now, if we have a modular application, we can actually go a step further. and we can start using all of the nice tools around the module system that are becoming available. And one of those tools is Jlink. Jlink allows you to create a so-called custom runtime image from your modular application. And what you can do is you can tell Jlink, so this is my root module. Please calculate for me the complete module graph that's necessary to run this application. So that will include our other application modules, it would include some of our libraries, and it would include any of the JDK modules that we need. And hopefully it will be a subset only of the JDK modules that we need. So for example, most applications don't use Corba or don't use the desktop APIs. And it will create for you a custom runtime image to create a tiny runtime that's just big enough to run your application. And you can use this to ship it to your customers or to use it as a base of your Docker image. And this is a really nice way to actually use the module descriptors that you already created, also to create a small custom runtime image. There are all kinds of optimization possibilities here as well. Won't go into detail. There's one caveat though. Jlink doesn't work with automatic modules. So for this to work, your libraries, the libraries that you're using, also need to have an explicit module descriptor. And they're coming more and more of these libraries, but this will take time. This is not something that will happen overnight in the Java ecosystem. So to recap, we had first a migration to Java 9 just using the class path. And the important point to note there is that you really need to address these warnings. So you should be able to run your code with illegal access is deny, and then you're ready both for the modular world and also for the future default of Java, where the illegal accesses will be disallowed. Then what we did was we created a single module around our application code just to tease out any of the technical issues that are still there if you're using, for example, automatic modules like we saw. And in the end, after we took this step, we were able to modularize the application, split it up into parts. And again, this is a process that's not applicable to every application, right? Some applications are just running fine on the class path, and they're maybe too messy internally to even think about modularizing, because modularization isn't just applying some keywords in the module info file, it's really thinking about the design of your application. What are the components? What are the APIs? What are the contracts between these different parts? So if you already have a strong structure in your application currently, then it's a prime candidate to also move to modules and to help preserve this structure. But if you're going to modularize a big bowl of spaghetti, that's just actually two big tasks in one, going from an earlier version to Java to a newer version of Java, and also modularizing your code, which can be a bit much. So if you encounter any issues when using the libraries, as for example automatic modules or any of the issues that we just encountered, I urge you to also reach out to library maintainers, make them aware of the issues, make them aware of the impact going forward of using encapsulated types, for example, of the JDK, so that we all can get the Java ecosystem moving forward. So a big question that lots of people have is, okay, so should I adopt Java 9 now or wait, or what's up with that? And we all know there are going to be 2 Java releases each year, and the first long-term support release will actually be Java 11 later this year. Should I wait for that? And I would advise to at least make a distinction between moving to another version in your production runtime environment versus your development and test stack. I think you owe it to yourself to at least in your development environments and in your build stacks, etc., to make it possible to test against these Java 9, 10, and other versions that are coming up. Because you will encounter lots of these small issues that will all snowball into a big issue if you're going to wait until Java 11, for example. So this is something that you can do today, and it won't affect your production environment. It will only take a little bit of development time, but that's time you have to spend anyway, right? If you're going to move to some future Java version, which I hope you're going to do, because there are lots of benefits besides even the modules that will come in. So yes, in your development, definitely do. For your production, environments, start thinking about what it means that these frequent releases of Java are coming up. So with that, of course, I would like to point you to the site around our book at javamodularity.com. It also contains the GitHub link that I talked about, so you can find all of the examples that I talked about. If you want even more content about Java 9 and lots of stuff around that, I also have some Pluralsight courses, so highly recommend it. And O'Reilly was so kind to also send me a few books to hand out after this talk. So what I'm going to do is, I mean, there's no such thing as a free book, right? So there's some strings attached. If you want a book, then after the talk, please come forward and only pick up a book if you're actually planning to read it. And also try to sort of start a study club in your company to see how you can use the book to actually migrate your code base. So if you're willing to do that, if you're willing to involve other people, then by all means come forward. I have a box of books here, and it will be first come, first serve. But for now, thank you for your attention. If there are any questions, we may have a short bit. No time for questions? Okay. Well, do come up anyway if you have questions, and we'll get it sorted. Thanks.